Hi, everyone. So my name is Mac Tafazoli. Really happy to be here to talk to you guys about safety, launch safety. So basically on that wheel that you saw that Carrie presented, I'm just going to look at that safety application review and just talk a little generically about it and some specifics. It's a very lengthy topic, though. So let me see, how does this work? Yeah, OK. So as Carrie mentioned, our mandate is to protect public. That's not just Canadian public, it's just all humans when we do authorize a launch. We're not there to regulate mission assurance. However, if you do your system safety program properly, understand all the hazards, all the malfunctions that can happen, and do it in the right way, you can actually increase your mission assurance. But that is not our mandate. Our mandate is really on an orthogonal axis, which is safety. Let's see. So basically, actually, I see the screen there. That's a little better. So what is acceptable level of risk? I mean, it can't be zero, right? I mean, it's not possible for any activity. You go out walking, take a car, drive, there is some level of risk. Risk is defined, so on that little top right-hand corner, as an intersection of three different things. Usually for project managers, engineers, you see two axes. You have a probability and a consequence. Here, the consequence is split in two. So you got a probability of failure. It's gray. There's a reason for that. It's difficult to actually assess the probability of failure for the rockets. But then once there's a failure, there's a danger area that ensues: toxic release, debris, inert or explosive, or it could be overpressure. And then the next piece is, okay, there's a danger area, there's a hazard area. Are there people there, or is there an asset there? If there's no asset, then there's no risk. So any of those things being zero, you get a zero risk, but there's a little bit of all of them in play, so you usually get some number. So that's how risk is defined. So our risk criteria right now, based on Part 450, are a protection of public at 1 in a million. So that's a probability of casualty. So basically means if you're at a stadium with 1 million seats and one of the seats was booby-trapped and there was a World Cup game, you were given a free ticket and say, hey, would you want to go see this ticket? There's possibility of casualty. Now, I would go. It's 1 in a million, so I'll go take a seat somewhere. So that's what it means. So we're trying to keep it as safe as general aviation. When there's an aircraft overflying, we want the same thing for a rocket overflying, making sure that it's that safe. And the collective risk is, how many people does the society want to allow to go to that stadium? And we set it at 100 people. We want 100 people to go attend, not more. Because if we send 1 million people, we're sure to have one casualty, right? So that's the two criteria. I won't get into the other rest of them, because that's not as important for this talk. I just wanted to give those two across. And then the point is, you got to prove that you're meeting those requirements. There's a whole bunch of flight safety analysis and all that. And you got to really use accurate data. You got to make sure you have scientific principles. And you use statistical methods, because all of these variables, everything is random. So there's a lot of Gaussian distributions for those of you who are statistically inclined. Okay, a little bit of statistics on actual launch failures. So this is stats from 1950s, 60s till 2024 or something like that. And you can see it drops sharply, but it's still around 5%. So that's a combination of all new rockets, reliable rockets, all of it together. You're still having about 1 in 20 failure. That's like 5%. So you can see that every rocket has quite a high chance of failure. If you compare it, for example, with aircrafts, the passenger aircrafts you get on, the reliability there is much, much higher. So this is 1 in 20. The reliability of an aircraft is 1 in a million. So we have to have additional requirements on safety to make sure we're keeping the safety of the public at the same level. And then as the number of launches are increasing over the years, the absolute number of failures and casualties are going up. It could go up because you have more and more launches, so more and more absolute number of failures. This is probably a little bit more interesting for the crowd here, because we're looking at developmental statistics here. So these are from Flight Safety Handbook from FAA, available online. Those of you who are building rockets, go look at it. There's a lot of details. It shows a chunk slice of time from 1980 to 2008, 16 rocket companies, or 16 rockets. Maybe there's one or two that are from the same company. I don't think so, but anyway, 16 rockets. You can see immediately from the first attempt, 80% failed, right? So that is matching the historical numbers you see on the left of the type of failures you have. So if those numbers are important, feeding into the probability of failure, and that is why we care a lot about safety, especially in the new developmental or experimental programs. Second attempt, actually, you can see that from 16, we dropped, 6 people dropped out. So 6 companies or rockets dropped out. Again, you get a little bit better. You get about 70% now. 7 of them actually failed, some failure. And then it gets better and better and better. But the good news is as well, there were 3 on the first attempt that, I think it's 3, that actually did work. So Falcon 1, for example, I think was on the 4th trial that Elon Musk team got it. So it is an inherently risky business, but things get better. But eventually on the steady state, you still have 5%. So just keep that in mind. Our requirements are there to mitigate all these risks, the hazards, which I just touched on, toxic, debris, and overpressure. Right now, our requirements, which are open to consultation and feedback, are really split in 4 categories. The real technical stuff, there are about 50 or so, and they target things that are going to affect the vehicle system or operation. So you really got to understand them and see how they would affect your system. So this system safety is supposed to be part of the design. It shouldn't be an afterthought. You want to eliminate hazards using the right design. And then you got, so an example of that is one of those examples of 10 to the minus 4 expected casualty. So that's a clear, must technical requirement. And then you got things like analysis requirement. You got to do a flight safety analysis with these inputs and assumptions and blah, 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 blah. And then you've got plans. You got to give us plans. And then you've got application requirements. So there are 4 categories, but really the core that are technical, there are about 50 or so. This is just, it's not an exhaustive list, but there are 3 main categories. So there's ground safety, so things like on-site public safety or explosive storage, lightning protection systems. Then there's the orbital stuff, the orbital safety once you're in orbit, during the launch period, which is not when you're actually operating like your satellite or anything like that, but just as part of the launch and disposal if you're doing it. And a critical piece, most of the requirements are actually on the flight safety part. So things like flight hazard control strategies and public awareness, disposal safety actually feeds into that one, and hazard areas. And there's other stuff, there's other parts. So this is just an example of all these different 3 groupings, and then all the safety requirements are trying to mitigate all these 3 risks. And I think I'll just end with maybe this one. So this is our, if you scan that QR link, is the same one Carrie showed. You'll have the requirements. There are 4 sections to it. Section 4 is, you're not supposed to be able to read all those things, but it kind of shows that big blue box at the bottom. That's flight safety. So it shows how important flight safety is. Not that ground safety isn't, but the one above in a small box is the ground safety requirements and subsections, and then you have the actual risk criteria. And then on section 5 is the spaceport or launch site safety, so like the energetic liquids, explosive sightings, lightning protection systems. And finally, Annex 5 is all the orbital safety requirements. So I think that was sort of the intent, was to make sure that those who are interested in this area, which it should be all of you, look at these requirements, give us feedback. They are based on Part 450, so we find they're pretty solid, but there's a way of innovating, and we want to hear back from the industry. The requirements, I mean, FAA, I'll finish with this. FAA has been doing commercial space launch approval since 80s. And there has not been one single casualty during this time for public. So that means the requirements are well established. This is a new requirement, performative requirement, that is a little bit more allowing innovation, not mandating things like you absolutely need a high reliability flight safety system. There are ways to show that maybe you don't need one, and then that's fine. We can show it. I'll end with that. Thank you very much.